Welcome back to Ronnie Explains. As you can see today we are having a very interesting project to handle. So very first I'm going to show you how to go about all this. So here we are. This page is where we are going to do our connections and also do our simulation so that we see how it operates. So very first I'm going to connect my potentiometer to my breadboard. So I'll connect it that way. Then I also connect my resistor to my breadboard. So I'll pick this resistor and also connect it there. Now I'll set the resistance of this resistor to 220 ohms. So 220 ohms. So I change these units to ohms, and that is done. Now, in doing my wiring, we need to understand the pins of this LCD. So we have the pin that is denoted as G and D. This is a ground connected normally to the ground pin of the Aduino. Then the next one that follows is the VCC, and VCC is normally connected to the power source. Then we have the one that is denoted as VO. VO is used to adjust the brightness, so it is the input pin for brightness control. Then we have the RS. RS is the register select pin. Then we have the read write pin. We have the enable pin, which in some LCD boards is always denoted as EN. Then we have from pin DB0 through to DB7. These are the parallel data input pins. Then we have this pin that is denoted as LED. It is the anode. Then we have the cathode. So we've familiarized ourselves with all those pins, and now what we need to do is now to do our connection to connect our circuit. So this is what we're going to do. We begin by connecting our ground to the breadboard and also our 5 volts power supply from the Aduino. So this ground over here is what we're going to begin by connecting to our breadboard. Then I also come to my 5 volts power supply to a breadboard. Then the next thing that I need to do is that I will have to now start connecting this ground. I'll connect the ground of the LCD to our ground, the one that we've made here. See, it is in line with this pin. So I will come here, pick this, and connect it to our ground. So it is well connected. Then the next that I also connect is the VCC. I said that the VCC is the power pin, so it is connected to the power supply. Then I also have the VO pin. So the VO pin is connected to the wiper. So that one is also done. Then I will connect the read write to the ground. Then I also need to connect my E pin. So my E pin will be connected to I will connect it to pin 11 of the Arduino. Then I also connect my RS register select button to pin 12 of the Arduino. Then I will now begin connecting my data pins together with those of the Arduino. So what I'll need to do is to finish up by connecting the anode and the cathode. The anode is connected to the power supply, and it is connected via the resistor. Then I'll also take my cathode and ground it. That is what we need to do in making the circuit. So we've already finished setting up our circuit. So what I'm going to do is I will come here. We have default blocks. These ones are indicating the default code. Come to that drop down button and select text. Then I begin by initializing the library of the liquid crystal by associating any needed LCD interface pin with the Arduino pin number that it is connected to. So I will have to initialize it by typing #include. liquid crystal dot h. So that is the library that we're going to use. The next thing that I need to do is I am supposed to declare all the pins that I'm going to use. Then the next thing that I now need to do is to set up my program by using the void setup. The first thing that I need to do is that I need to set up LCD number of columns and rows. So I'm going to say lcd.begin. Then I set up the columns and rows. I have a total of 2 rows and 16 columns. So I have 16 columns. Then I have 2 rows. So that one is done. I also have to print something on the screen of the LCD. So I will set up what's supposed to be printed. So I'll use lcd.print. I'll use lcd.print to print whatever I want to appear on the screen of the LCD. So I want this LCD to display the following text. Please subscribe. Please subscribe to Ronnie Explains. That's what I want to be shown on the screen. So after that, the next thing that I need to do, I will have to delay this after it has been printed. After this has been printed, I'll want to delay it for some time. So I'll put a delay of 1 second. So I just put 1,000. That is 1,000 microseconds, like that. Okay, now the next thing, I go to my void loop where I'll be putting the block of code that is supposed to be executed. So I'll just type void loop, then I put those two brackets and I open my braces. It is inside the braces where we're going to put that block of code. So inside here, because I want this thing to be executed continuously, I'll have to use a loop. So let me choose to use a for loop. I'll just use for loop. Then I will type int I, which is now a variable, and I assign it a value of 0. Then I want this to, I want my text to always be scrolled towards the left side of my screen, and I want it to be scrolled 50 times. So it will be scrolled 50 in 50 different positions as it comes like this. By the time it finishes, then it begins again to be scrolled. So I will come here and I say I is less than 50. Then I type I++ and I close that bracket. So then in the body of this for loop, is where I'm going to type the code segment that is supposed to actualize the scrolling. So I'll say that it is lcd dot scroll display left dot scroll display left. Then I put those brackets and I terminate that line of code. These ones are default statements. The scroll display left, it is found inside this library and it is default the way it is. If you make an error of maybe writing any of these letters in a different case apart from the one that is displayed, then you are going to incur an error. So after it has displayed towards left, I want it to delay by around 150 microseconds. So I will delay it. I'll put a delay of 150 like that. Then after all this loop has been actualized, has been performed, or has been executed, I also want another delay. I want to put another delay of 100 microseconds. So I'll put a delay of 100 microseconds. Then I finish that using a semicolon. Our program doesn't have any bugs, so it is running well. So these things, they do work. If you are interested in making some of these projects, always feel free to follow my videos. I'll always be posting the Arduino projects and also doing the normal programming that we've been doing. So please feel free to email me in the emails that I will always be putting in my in the description. If you have any inquiry, I'll always try to respond to them promptly. So I hope you've enjoyed watching this video. Uh, if you've done, do me the honor of also sharing to some of your friends. And I wish you all the best. Have a nice time.